Hello, everybody. We're super excited to be here. Thank you for having us. I'm CIPRIAN, and this is ALEXANDRA. We founded Morefull, where we use machine learning to predict user behaviors in mobile and web applications with the end goal of increasing user engagement and conversion rates by enabling a personalized user experience. We started at the beginning of this year when we got a grant from Google, Digital News Innovation Fund, which is kind of like a partnership between Google and publishers in Europe to support journalism through technical innovations. And a month ago, we also got another grant from European Data Incubator. Now, before we start with the presentation, maybe I can tell you a little bit about myself. So I'm also one of the organizers of Bucharest.js, which is a JavaScript meetup in Bucharest. We started in 2015. We now have over 3,000 members. We also organize JS Hacks, which is a hackathon happening once per year in October. And starting this year, I also got involved with JS League, which is where we organize workshops for, surprise, surprise, JavaScript developers that want to kind of level up and lead. Personally, I'm passionate about machine learning and the intersection with web. And that's something that I'm going to talk about today. And that's pretty much about me. Alex, you want to say something about you?
So, hello, I'm Alexandra. I'm co-founder and CTO at Morefull. I have participated at 2 business accelerators so far, Startup Bootcamp in Copenhagen and Prosper Women Entrepreneurs in the United States. I'm a software engineer and I have experience in leading teams. For example, at Morefull, I'm involved with the machine learning side, big data, and also leading the technical team. I'm also co-founder of a community for women interested in IT&C called Codet. At the moment, we have over 2,000 members. That's it about me.
Cool. Awesome. Thank you. By the way, we have 3 t-shirts with Morefull that we intend to give away for those of you who will ask questions. And if you don't ask questions, I will ask you some questions. So that's another way you can win those t-shirts. And we also have stickers. So we'll see how this goes. So the presentation has 2 parts. The first part, I'm going to talk about the context, the use cases. We're going to look at some AI-enhanced products and initiatives in this space, and then Alexandra is going to go through the technical, go deeper into actually building a big data architecture, big data and machine learning architecture to support some of these use cases. Okay, so let's just dive in. So when it comes to data, we tend to think in dichotomies, quantitative versus qualitative, objective versus subjective, messy versus curated, science versus story. But using data for product development doesn't have to be either or. Instead, it should be yes and. And we know that product development process usually takes or consists of a few important phases like planning, design, development, and launch. And to increase engagement and conversion rates, this process undergoes multiple iterations, which us as developers, let's be honest, we seldom navigate by looking at the data. Usually there's somebody else, being a product owner, a business person like a salesperson or marketing that's looking at the data, analyzing it, and feeding developers a feature list that needs to go in the next product release. Well, in my opinion, there lies the gap between developers, business persons, marketers, product owners, salespeople, and users, which leads to a lot of guesswork. And that's why organizations worldwide have started developing metrics that go beyond the off-the-shelf analytics provider. Say, for example, rather than relying on page views or clicks to determine conversion, the trend nowadays is to use machine learning to draw insights from multiple signals and event streams. And let's look at some AI-enhanced products and initiatives in this space. And while we do that, I would like to invite you to think, how can you actually use some of this stuff into your own mobile or web application? How can you improve the experience for your users within your product? Right. So for the first use case, I would like to start with Google. So anybody knows what this is? Give you a couple of hints. So Google, well, presented this year in May, Google I/O. Anybody care to? So what this is? What is this? Google Assistant. Okay, it's close enough. There you go. Okay, cool. I was about to give a T-shirt for that, but it was too easy, right? So, so this is actually Google Duplex, which has been demoed this year in May at Google I/O, and apparently it's a technology that is capable of making phone calls on your behalf. Ooh. Now, if you're like most people, you're either super scared about it or, super excited. And I have yet to see a person that is both scared and excited at the same time. But the reality is that the technology, sometimes works, other times doesn't really work. So it's still in the early days. But from Google comes another thing that is more down to earth and applicable today, which is app actions and specifically predictive app actions in Android Pie. So last year, Google introduced this notion and this concept of predictive apps in Android, a feature that places the next app a user is going to use on the path it usually takes to launch that application. And Google says that that has been very effective with a 60% prediction rate. Usually 60% when you talk to a machine learning guy is not, a lot, but still for them that was effective. And then with Android P, which is now known as Android Pie, Google took it a step further into predicting the next action a user is going to take into those apps. Say, for example, you plug in your headphone. So, and your operating system, your phone, will suggest to resume probably your favorite Spotify playlist. Now, if you think about it, this is incredibly useful for user retention. And is anybody here that is building mobile products? Have you guys tried this one yet? Because if you didn't, I would definitely encourage you to check it out. And another thing is that this is happening at the OS level. And I'm wondering, how can we actually borrow this concept into predicting the next action a user is going to take while he is navigating through that application? Or could we apply the same concept on web? For example, if you have an e-commerce, to improve performance? Well, apparently you can. And the first time I saw this, it really blew my mind. So what if we can combine these two worlds of machine learning and web, blend them together to improve or to increase performance? Enter Guess.js. Did you guys know about this stuff? Guess.js? No. Cool. So it's an open source project focused on data-driven experiences for the web. Now, I'm not going to go into too much technical details. So I'm going to explain the high-level concept. What they do, they take advantage of Google Analytics data, and they use machine learning to model the next page a user is likely to visit. And in doing that, they improve the page load performance by prefetching or preloading the resources for that page. And in doing that, Guess.js introduces this notion of data-driven loading for websites or web applications in general. And this actually has impact on the bottom line, on the revenue, on the return on investment, if you want. Because if you plot the chart, conversion rate versus load time, you can actually see how much money you're wasting, you're leaving on the table, or how much money you could make by just improving the load times. Guest.js works, as far as I know, with Angular and React, and you can use it. It's on GitHub. You can check it out. For the third use case, by the way, anybody, I know that this is a conference for developers. Any marketers in the house? Probably? No? Nothing? Cool. So another interesting use case is predictive marketing campaigns. And this is exactly what the marketing team at InVision did. Do you guys know about InVision? So InVision is a prototyping tool. They have over 3 million users, so it's pretty cool. So as a marketing team at InVision, what they are set out to do is to actually acquire users and activate them to their paid plans. So last year alone, to do that, they sent over 500 email campaigns, ran over 250 ads across 6 different channels. But it's interesting how they did that. Instead of actually spending all their money on targeting all the users, they relied on machine learning to target only the top 25% of users most likely to create a prototype within a given week. Then they set up a persistent marketing campaign to target only these 25% of users with their Facebook ads and HubSpot emails. And only in 1 week of running this campaign, they found that email click-through rate increase 40%, that's a 40, and click-through rate on Facebook ads 70%, that's 70. Now, I don't know about you, but this is, for me, this is impressive. And apparently, this is how you do it. This is like modern marketing, I would say, or marketing plus machine learning to the rescue. The fourth use case, I'd like to refer to a McKinsey report from 2016 that says that travel companies in airlines in particular have 23x greater likelihood of customer acquisition, 6x customer retention, and 19x larger likelihood of profitability if and only if they are data-driven. And this is something that Airbnb knows and applies throughout their platform. Any Airbnb users here? Cool. Any Airbnb hosts? No? Well, Airbnb show hosts, and this is just one example, the probability of getting bookings, green for higher chances, red for lower chances, based on their pricing. So this is hugely valuable for hosts to accurately price their rooms or their offering. And this is, again, this is only one example, because Airbnb implemented machine learning strategy to optimize user travel experience, not only the user experience within their mobile or web applications. So for detecting hosts' preferences, to predicting customer lifetime value, and to offer listing recommendations. And they actually wrote about this stuff on Airbnb.io, where they have all their open source projects, and they also have a blog on Medium. Strongly encourage you to have a look, because these guys are super awesome. Now for the fifth use case, and this is where things become serious, I would like to leave Alexandra.
The fifth use case that I'm going to present is going to be more detailed, and it's actually something that we implemented as part of the Morefull platform. As part of our application to the European Data Incubator, we worked on a proof of concept that basically meant classifying user intent based on search keywords. And this challenge was submitted by a company called Jot Internet Media. To give you some context, they're not a typical digital agency. So they work with a lot of keywords. They have approximately 5 billion long-tail keywords. And they have automated a lot of their processes. So basically what they do, they have an internal tool where they push the ads and the ad copy automatically to Facebook ads and Google ads. And for them, applying machine learning to optimize, for example, the click-through rate and the cost per click for ads is very important because this will directly translate into optimizing their costs. To give you some context about Morefull, Morefull is a platform that uses machine learning to predict user behavior in mobile and web applications and enables increased engagement and conversion rates by personalizing the experience of a user. Basically, what we do is that we deploy machine learning models on top of data pipelines, and we make them readily available for software engineers that don't necessarily have machine learning or big data knowledge. We launched the community edition at the beginning of September, and we are currently working on the commercial version targeted towards digital media companies to be launched at the end of this year. The commercial version will have a user-friendly dashboard that will enable you to select the data source API and connect it to a machine learning model. And once you do that, the model will be trained and predictions will become available in the dashboard, but also exposed via an API endpoint. So this is like the user interface, how the dashboard will look. But to give you more context about the architecture, I should specify that the community edition has two main components. We have what we call the Morefull Orchestrator, and we have a series of machine learning models. And here you can see just some example of these models. The Orchestrator is the backbone of the platform and sets up the big data tech stack required for running Morefull. It is built with scalability in mind, and we use tools such as Spark, Kubernetes, Airflow, Hadoop, and so on. And the Orchestrator has the capacity to handle data ingestion, training models, and exposing predictions for multiple machine learning models at the same time. The community edition can run on a single virtual instance, so it's really easy to set it up. And it takes advantage of virtual CPUs for parallelism, and of course can be easily migrated to a cloud platform such as AWS or Google Cloud Platform. The Orchestrator is basically a series of shell scripts that install all the required dependencies, so the setup process is fully automated. And once the setup process has finished, it runs a series of pipelines that ingest data and train models, such as predicting the next shopping stage for users using Google Analytics data from the enhanced e-commerce section, predicting churning users, and so on. This is an overview of the architecture for the pipelines for a single model. Oops. Okay. And for each model, 3 pipelines are created. We have the ingestion pipeline that handles connecting to various data sources APIs. And what it does, it gets the data from the APIs. For example, if we have a model that uses Google Analytics data, the ingestion pipeline uses a service account, connects to the Google Analytics REST API, gets the data, and saves it into Cassandra tables without applying any kind of additional processing. This pipeline runs daily, and it can also handle backfilling. So if you have historical data, you can immediately get the data and train the model. Then we have the training pipeline, which consists of preprocessors and model training. And we have 2 types of preprocessors. One is the PySpark preprocessor that handles everything from formatting, cleaning, deduplicating, and normalizing data. And we have an optional Dask preprocessor that can handle additional transformations. And from our experience, we saw that the most complex part of the pipeline is usually the PySpark preprocessor, because it needs to take the data in raw format, which can be a JSON, and transform it into SQL-like tables until it is ready to be fed to the model. And after each transformation is applied, the data is saved, the intermediary data is saved into Cassandra tables. So if anything goes wrong, we can backtrace and see exactly what happened. Once the model is trained, the model file is saved into HDFS, and we handle model training using Keras and TensorFlow. And finally, we have the prediction pipeline, which receives a series of parameters. For example, if you have a user, you send the user ID, and generates predictions that are exposed via an API endpoint. The API endpoint is exposed via a Docker container, and the infrastructure can be easily scaled as components are part of a Kubernetes cluster. All public API endpoints are secured using Let's Encrypt certificates that are automatically installed by the orchestrator, and for authenticating all the requests, we also use JSON Web Tokens. Now, this is the infrastructure overview, and I should specify that before we actually go ahead and implement these pipelines for a model, we create a proof of concept. And this was the case for the AD challenge as well. So, this is what we had available from the Jot Internet Media Company. We had a CSV file with approximately 15 million rows that spanned various languages and multiple categories. And here you can see a sample row from that data set. And you see that by keyword, we actually mean a group of words or a query. The first thing that we did, since vocabulary tools are highly dependent on the language, we applied language detection. We grouped the keywords by using the ID of the group, so we have more context than just 3 words. And we ended up with approximately 4.5 million English keywords. We didn't use the ID of the keyword at all, and also the date. You can see here, but the date was the same for all the columns in the data set, all the rows in the data set, so it was not useful at all. Next, we defined the problem as classifying keywords based on user intent. And we did a lot of research and found a paper from Google that was released this year that classifies the user intent into the following categories: informational or no, meaning finding information about a topic; transactional or do, which means accomplishing a goal or engaging in an activity; and visit in person or website queries. We couldn't distinguish between visit in person or website queries because we didn't have any kind of context for the device that was used for searching those keywords. For example, if we had the device as being mobile, we could say that that query has a higher probability of being a visit in person query. Or if the device is desktop, then it can be a visit website query. But we didn't have that, so that's why we decided to group both of them into this category called navigational. Also, since the intent of some keywords can be highly ambiguous, we can't, even as a human, you can't exactly know what the user meant when he searched those keywords, we decided to use multi-intent. So this is the part where it got complicated. The data was not labeled, so we had to get creative and find various ways to auto-label the data. And the first thing that we did for evaluating the results was to create a test set of our own. We manually labeled 1,200 random queries from 3 different sources, and based on those, we created 2 test sets. One where 2 sources agreed, and the other one when 3 sources agreed. For the auto-labeling part, we applied that to the data set, and we split the data that was auto-labeled into 2 parts, the training set and dev set. And then we went through an iterative process where we auto-labeled the data, we trained the model, and we evaluated the results based on the test set. We also considered using unsupervised learning, for example, such as k-means for grouping the keywords based on user intent, but it seemed more like an uncontrolled process, so that's why we decided to stick with supervised learning. This is our sheet for the methods that we created for auto-labeling the data. We started by doing research. We found research papers, for example, that used a list of target words to label the data, and that was version 1. Then we iterated on that. We tried using synonyms. It didn't work. We also tried to combine labeled data from multiple sources, from the paper that we found and from a service called TwinWord. That didn't work that well either. And finally, in version 4, we decided to use more like an empiric process where we manually created a list of target words and splitted them into the 3 categories: informational, navigational, and transactional. As you can see, version 4 had a really good result, even though it was like a naive regex search based on a list of target words. So for example, if you had like a keyword containing the word buy, then it would be labeled as transactional. Of course, this has one main disadvantage, that if you have a keyword without any of those target words, it wouldn't be labeled. So that's when we started using word embeddings. And the best results for that was given by version 7, which is basically, we kept the same list of target words, but we calculated the distance between those and the keywords that we had. And if that distance was within a certain threshold, then we will label that word with the intent category. In version 8, we also try to automate that part and do a grid search, where we would use different similarity functions and different word embeddings libraries, and also vary the threshold. But unfortunately, the results were not improved from version 7. Then we tried 4 different models. We started with a very simple model, RNN linear, then moved on to an RNN nonlinear model, LSTM, and even the last one is inspired by a paper that uses convolutional neural networks to label the data, to define the intent of sentences. And interestingly enough, the results were not improved by using a more complex model. And we assumed that this happened because we had few features. We only had the word embeddings from the keywords. So it wasn't required to use a more complex model. This is just an overview of the results. We tried 70 different combinations of auto-labeling the data and using different word embeddings, and again, train. And we trained on both the entire English data set and the first million keywords for faster iterations. And the best results were given by an RNN nonlinear model that uses our auto-labeling version with word embeddings, and one-hot encoding when training the model. And the data was auto-labeled using word embeddings calculated with GLOV 100. So we had 79% on our 3 agreements test set. Here you can also see some predictions examples. If you look at the first 4 rows, you'll see that they have been labeled correctly. Unfortunately, for the one at the bottom, it couldn't have been labeled correctly because it's a brand name, it's Macy Ferguson, and there's nothing to tie that word to a target keyword. In this case, it should have been seen as a navigational keyword, but it wasn't labeled correctly. And we think that we can improve these results. For example, if we do named entity recognition, then we will be capable to more accurately distinguish these kinds of situations. So this is what we think that can improve the results. Manually labeling a dev set. So our dev set was part of the data that was auto-labeled. So of course it wasn't from the same distribution of our test set. When training, we had a really high score for the accuracy function. But when we compared the results with the test set, of course, the results were lower. So this is our next go-to, manually labeling a dev set, and then we can, while training, we can evaluate the results based on that. We haven't tried so far to do a grid search for model training, so that might work as well. And of course, we can also benefit from adding more context to the data. So if you know the device, the category that was used when performing the search, that would be an extra feature that will provide a lot of insight into what the user meant when doing that search. Also, a more accurate detection for geographical location and brand names would enable us to more correctly label navigational queries. And of course, we can't talk about true user intent unless we add more context to the data. So we had only the first part of the funnel, when the user searches and before reaching an actual website. And for example, if we have more information, such as the user shopping activity, once he reaches the website, then we would be able to more accurately know what the intent was based on his purchases, for example. And we can do that by combining the keywords with the shopping activity from the website, basically Google Analytics data. And that should provide a very accurate picture of the real return of investment. And the next step after we have a baseline for this model would be to actually implement the 3 pipelines and have everything available in the Morefull Orchestrator. Once we have that, the setup process is really simple. You just start a virtual machine, you download the code, set up the credentials for ingesting the data from Google Analytics and the Google Ads API, and create a DNS record for the API domain. And once the setup scripts are installed, are run, everything is up and running, and the predictions are exposed as part of an API. So this concludes my presentation. Thank you for your attention, and looking forward to your questions.
Regarding the labeling, how long was that process in time or number of persons labeling everything by hand and through scripts, regex? How complicated is the full labeling process?
So you mean how much time we worked on it?
Yeah.
So the whole process was about a month, because we had a deadline for submitting the proof of concept. So yeah, it was about a month. It was fairly complicated, and we had to get creative at some points because we didn't have that many options. Our first ask was to go to Jot and ask for more data, but it didn't have any additional data. This is the data that they used to generate their ad copy based on templates. So they just have only the first part of the funnel for this particular use case. So, yeah.
And you also said that some of the information you found in the papers. Is it not too well structured on the internet, this kind of thing? You need to read special dedicated papers for this, or there are a lot of content on the internet on how to do this?
There is a lot of content, but most of them do sentence or, for example, tweets classification. So we weren't able to find an example that uses just keywords. I think this was our main problem. We didn't have a lot of context. So we just had like 3 words, and based on that, you should classify the user intent. And we did find some papers, but they weren't that useful in the end. So, yeah.
Did you find anything about more complex thing like a kind of sentence embedding instead of word embedding to have bigger context? I don't work with word processing, so I'm not up to date with latest findings. So do you find something like that?
So even the word embeddings representations that we use, like GLAV 100, GLAV 300, are trained on corpus data from the internet. So most of them use sentence or texts for classification. So we didn't find anything that was just for our use case. I'm not sure if I understood your question correctly.
Okay. And another question is, I'm a bit surprised that you didn't use k-means at least for your, let's say, validation or check if embeddings works correctly. It is quite a natural way to create clusters and see if clusters are correct or not correct and see what's happening there.
Yeah, we did think about that. I think the main reasons that we didn't go on with k-means was because we were running out of time. So we had to get something done quickly. And then we made like a guess that if we proceeded down that path, then it's very likely that the keywords could also cluster by category, for example. So we had keywords from all the categories like automotive and fashion and everything. So there wasn't, it looked like a lot of random data in there. So we weren't sure that if we went on with k-means, then we will have like an accurate classification at the end. So that's why we decided to drop it and focus on supervised learning. So.
Okay, thank you.
Maybe you told that, but I didn't hear. Your training data was actually people's Google searches and their classification into some labels, yes?
Yes.
How did you get this data? Is it available for everyone, or I want to have all the people's searches, you know?
So the data was provided by the Jot company, so it was their data. I think you can have that. So for example, if you have a website and you connect it with Google search, you will actually see in your Google Analytics data, you will see that the queries that people use to get to your website.
Not in Google Analytics, in Google Search Console.
Google Search Console, okay.
And if you have Google Ads, then you can have that, but you have to pay for Google Ads to have a lot of.
But do you have like a full set or just the set for your searches, like that lead to your website?
Only the ones.
Okay, so how can you assure that your learning is not biased by some context, if you know what I mean? So your data was only the ones given you by this company, yes?
Yes, but what they do is they do this for multiple websites. So their data was actually a mix from multiple websites and searches. So this is what they do because they're like a digital agency. To answer your question, I think that even if you're a website owner and you optimize only for your website, it should work as well because basically that's what you want to do. You want to optimize for users coming to your website and you have a specific use case. So
maybe yes, but then
I haven't tried it yet, but my bet is that if you have enough data, so if you're like a bigger website, then the users coming to your website will be diverse, and you can use that for training a model.
Well, very interesting presentation. Thank you.
Thank you.
One more question. Maybe I missed this during the presentation. You said that you auto-labeled your data after first manual labeling. So you did some first simple model and used that for auto-labeling and extended with new data. It's kind of this kind of approach?
Yeah, so the test set was manually labeled. It was like our human level, so we can check the results that our model is actually working on something that's human labeled, you know. So it was quite difficult because even if you, as a human, look to the keywords, the intent is not clear at some point. So if I search, for example, just imagine that I'm searching, for example, a laptop, and I just write laptop and the code of the laptop. Is that a transactional intent, or is it more like an informational one? So that's why we felt the need to control the process and go in and manually label some test data. And for the other part, for the bulk of the data, we used scripts and auto-labeled them. But we had...
What do you use for auto-labeling?
It's just something that we created. So we just wrote a Python script and calculated the word embeddings, and we used basically the threshold and calculated the distance between our target words and the keywords from our data set. So it's something that we created.
Okay, thank you.
So I have a funny story regarding this. So we first did a regex search, and then we decided to go in and started using word embeddings. And my assumption was that if we do that, it will work even better than the regex search, because what other motive we will have to do that? And we did that, and my colleague that handled the machine learning part trained the model, and the results dropped from, I think they were like 65, 70% to 35%. Like, how can this happen? And he was ready to, bury it, saying something like, okay, look, we tried, and let's move on. But then we figured that we basically inverted two column names in the results from the model and our test set. So when it was comparing them, it was comparing two wrong columns. So yeah, that was like our down moment. So what we got back from that. And after he fixed the bug, got back to 70%. So fun times. Yep. Any other questions? We have t-shirts, so.
I still have to give these guys 2 t-shirts because they were really going
yeah.
to the questions.
Okay.
Did you use Python or this? Oh, okay. As a programming language, did you use Python?
Yes, we use Python.
And Java or something like that?
No, we didn't use Java. And even the Morefull Orchestrator and the components are implemented in Python. So we don't have a lot of experience in Java. So.
Thank you.
In JavaScript, yes. Okay, so should we go to lunch?
Yeah.
Yeah? Okay. Cool.